Hello students and welcome to a new lecture. This lecture is about mass relationships in chemical reactions. A chemical reaction, which is how we describe what happens between two different reactants to form two different reactants or more. Of course, we try to simplify it here and keep it to two reactants, but it can be more. And how it can they can transform themselves into new product, forming a new substance. That's what we remember. If you remember our discussion about a chemical change, which is a chemical reaction, how do we know that we have a chemical reaction? We know that because we form something new. Every time we write a chemical reaction, we do have to specify the physical state of our reactants and products. So if they are solid, we're going to abbreviate that by a small s, liquid with an L, gas with a G, aqueous, which means dissolved in water, with a Q. The law of conservation of mass states matter cannot be created or destroyed. It just leads to a balanced reaction. So if you look at this reaction here, you will see that we do have two molecules of hydrogen gas reacting with one molecule of oxygen gas to give me two molecules of water. And if you look at what happens here, we have a total of 4 hydrogen atoms in the reactant. We still have that. And we have a total of 2 oxygen atoms, and we still have that. So matter cannot be created. It's not going to come out of nowhere, nor it will be destroyed. It will be converted to something else. This picture here to show you what does aqueous mean. So what we have in this beaker is a sodium chloride aqueous, which means sodium chloride is dissolved in water. Let's balance chemical equations, right? The simple rule that I give my students is what goes in has to come out. And that comes from what we just discussed, that matter cannot be destroyed nor created. So what goes in has to come out. So we write the correct formulas for reactants on the left side of the equation and products on the right side of the equation. That's how we write a chemical equation. We remember our diatomic molecules. So for example, if I told you substance X reacted with oxygen gas, you have to remember that oxygen exists naturally as diatomic molecule. So it's O2. If I am referring to hydrogen, it will be H2. To nitrogen, it will be N2. To chlorine gas, it will be Cl2, and so on. We change the coefficient when we balance the equation, which is the number in the front, and we do not change the subscripts. Let's see why. For example here, if I needed to balance my equation and have 6 atoms of carbon, then I put 2 of the compound C3H8 and not C6H6. The reason for that, because if you change the subscript, you are changing the compound. This here is a totally different compound than this one here, right? So if I want to change number of atoms for this compound to balance my equation, I only change the coefficient. Okay. Now we're gonna keep this equation at the bottom till the end after we learn all the rules of how to balance the equation, and I will come back to this equation and balance it with you. Now it's also very important that again we do not, for example, if you need 2 oxygens to balance carbon monoxide, then you're going to put 2 carbon monoxides. You're not going to put CO2 because again carbon dioxide and carbon monoxide are not the same thing. So, when we balance chemical equations, we start with elements that appear the fewest in compounds, and I will show you what do we mean by that. That will lead us to sometimes balance metals before non-metals, and we start with the most complicated molecule, and you will see examples as we are really balancing equations. Then we balance other elements, and free elements like oxygen gas, for example, should be balanced last. We check to make sure that it is balanced, and I will show you how we do check on our numbers to make sure that our balance is correct. And we reduce the coefficient to the lowest whole number. So we get rid of any fraction if balancing had led us to fractions. Now, also a great tip that I can give you when you balance equations is to treat polyatomic ions as a unit. So here is an example. When you are balancing this equation and you want to balance sulfate, if you try to balance sulfur individually and oxygen individually, you are just complicating your life, and it will make your life really harder. However, what you can do to simplify your life, you can say, I have 1 sulfate here and 3 sulfate here. So I need to balance, for example, by adding 3 to this side. Right? So I look at sulfate as a unit, not as individual atoms. When an element is in 3 or more compounds, change the coefficient where it is alone. You can even use a fraction, and we will again run into an example. So let's balance these 2 equations since they are right here in front of us, and learn how to apply those rules. So here it is for the first equation here. Aluminum reacts with iron 2 sulfate to give me aluminum sulfate and iron. The rule says start with elements that are mentioned the fewest. So if you look at aluminum, it was only mentioned once in the reactant side, and once in the product side. Right? Which means, this is the fewest it can possibly be mentioned, to be mentioned once in the reactants and once in the product. So the way I balance, I said, okay, here I have 1 aluminum in, here I have 2 aluminum out. In order to balance that, I have to change the coefficient, so I'm going to put 2 here. Now, I go to iron, and iron is also mentioned once in the reactants and once in the product, so I can keep going with iron. Iron is mentioned once for 1 atom at both sides, so I just leave it alone. And now we did talk about sulfate as a unit. I have 1 sulfate in and 3 sulfate out, so to balance that, I'm going to have to put 3 here. That did ruin my iron, so I go check on my iron. 3 iron in, 1 iron out. I fixed that by putting 3. Now let's check that I did my balancing correctly. On the reactant side, I have 2 aluminums. On the product sides, I have 2 aluminums. On the reactant sides, I have 3 irons. On the product side, I still have 3 irons. That's the check. On the reactant side, I have 3 sulfate. On the product side, I have 3 sulfate. I am done. All right. Now let's look at the next reaction here. If you look at this reaction, you will see that nitrogen is mentioned once in the reactant and once in the product, so that's a good element to start with. Hydrogen is mentioned once in the reactant, once in the product, so that's a good element to start with. So the complicated element really here is oxygen. And the way to treat oxygen in this case will be, so I have to think of the following. Hydrogen is balanced. I have 6 hydrogen in, 6 hydrogen out. Nitrogen is balanced. 2 nitrogen in, 2 nitrogen out. So it is easier to play with this coefficient, since if I put any coefficient, it will not ruin nitrogen or hydrogen for me. So how am I going to do this? I'm going to say, okay, on the product side, I have 3 oxygens coming from water and 2 oxygen coming from nitrogen monoxide. Together, that is 5 oxygen. Now, I need 5 here as well, right? Now, I need 5 oxygen to come out of this. However, I have O2, so which means 2 oxygen. So what I will tell myself, what is the fraction that if I multiplied by 2, which is the number of oxygen in O2, will give me 5, and that will be 5 over 2. Does that make sense? Because 5 over 2 multiplied by 2 will give you 5. So this way I balance, this is oxygen and this is oxygen here. I will get 5 oxygen at each side of the equation. So what I'm going to do now, I'm going to rewrite my equation and I'm going to say, okay, 2 ammonia gas plus 2.5 of oxygen gas will give me 2 nitrogen monoxide and 3 water vapor. Now, we don't like fractions, right? Because right now we are viewing it as atoms and molecules, and we do not have half of atoms or half of molecules. If we're looking at it in a quantity moles, we can definitely do the fraction, but not in this case. So what I do, I multiply my whole equation by 2 to get rid of the fraction, right? And if I do so, the new equation will look like this. It will be 4 ammonia reacting with 5 oxygen to give me 4 nitrogen monoxide and 6 water vapor molecules. Now let's do your check. You have 4 nitrogen in, 4 nitrogen out, 12 hydrogen in and 12 hydrogen out. Let's look at the oxygen. 5 times 2, you're going to get 10 oxygen in. You're going to get 4 here and 6 here. So 10 in, 10 out. Your equation is balanced. I hope you enjoyed this example. Now, think of water as H and OH, which is one way to deal with water when you balance it. I will talk about that, although I think that you can do this without, resorting to that method. So let's balance this equation and see how we will work on it. Magnesium hydroxide react with hydrogen chloride to give me magnesium chloride and water. Let's balance this equation. Let's start with our rule. Magnesium is a good element to start with. It was mentioned once in the reactant and once in the product. 1 in, 1 out, all balanced. Leave it alone, right? Now, let's do chloride. Chloride is mentioned once in the reactant and once in the product. It's a good one to start with. I have 1 chlorine in and 2 out. To balance that, I'm going to put 2 here. Okay? So now oxygen will be a good molecule to look at. I have 2 oxygens in and 1 oxygen out. To balance that, I will need to put 2 here. Now, if you look at your equation, 1 magnesium in, 1 magnesium out, 2 oxygen in, 2 oxygen out. You are having 4 hydrogen in. Hydrogen should be left at the end because it's mentioned twice in the reactant. So you have 2 in the magnesium hydroxide and 2 in the hydrogen chloride. So, and here in water, you have also 4 hydrogen out. Now, 2 chlorine in and 2 chlorine out. Your equation is balanced. You can move on. Now, practice those problems and try to balance them based on what we have covered in the previous example. But we're gonna go back to the combustion of the propanol. So if you remember, I told you I'm gonna go back and talk about this here, which is we're gonna be doing the combustion of a propane and propanol in the next slide. So let's do this together. First, let's start with propanol, and then we're gonna talk about propane. If I am combusting, I need to know the definition of combustion, and combustion is burning a molecule in the presence of oxygen, which means oxygen is a reactant to give me carbon dioxide and water. So if I do combustion here, I will have C3H3O reacting with oxygen gas to give me, now carbon will be oxidized into carbon dioxide and hydrogen will be oxidized into water. Now let's start to balance. Carbon is a good element to start with. I have mentioned once here and mentioned once here. 3 carbons in, 1 carbon out. I balance that by putting 3 carbon. Now let's look at hydrogen. 8 hydrogen in, 2 hydrogens out. I balance that with putting 4. Now oxygen, remember we're gonna do our method again. This is easier to play with. However, this time I have a more complicated situation because I have also oxygen twice in both reactants and products. So let me show you how I actually work around that so it's not complicated. From water, I'm gonna have 4 oxygen. And from carbon dioxide, I'm gonna have 6 oxygen. Together is a total of 10 oxygen atoms. Okay? Now, in the reactant side, I also need 10 oxygen atoms. However, one of them is coming from propanol. So from O2, I need 9. However, since it's not O, it's O2, I have to say it's a fraction, 9/2. So my coefficient here will be 9/2. Now what I will do, I'm going to get rid, as I have taught you, from the fraction by multiplying my equation by 2. And now I'm gonna get 2 propanol molecules reacting with 9 oxygen gas to give me 6 carbon dioxide and 8 water molecules. Now if you do the math, let's balance. You have 6 carbons in and 6 carbons out. We have 16 hydrogens in. We have 16 hydrogens out. And for the oxygen, we have 9 times 2, 18, plus 1, 19 oxygen in. And here, what we have is 8. Sorry, I did sorry, it's a 20. I'm so sorry. Let's do the math again together, okay? So what we have here is we have 18 oxygens from 9O2 and 2 oxygens from propanol. So 18 plus 2, that will give you 20 oxygen, right? And here you have 8 from the water and you have 12 from carbon dioxide. So that will also give you 20 oxygen on this side. and that makes our equation balanced. What I would like to tell you that the good news that this example is almost as hard as it gets when it comes to balancing equations. So if you follow this logical method to go around the atoms and how to balance equation, you will be good. Okay, now let's do propane. So how would you balance propane? You combust propane with oxygen. That's going to give you carbon dioxide and water. You balance again. 3 carbons in, 3 carbons out. 8 hydrogens in, 8 hydrogens out. Now 4 oxygen on this side and 6 oxygens on this side. That's 10. And I don't have any oxygens here, so I only have to have 10 out of O2, which means I'm going to have 5. And your equation is balanced. Cool. Let's go and meet again in our next lecture about stoichiometry.